Cool. Yeah. So my name is William, and I'm talking a little bit about some work that the company I work for, TrailofBits, did on PyPI, specifically this feature that we call trusted publishing, how we built it, how we deployed it, and how other ecosystems can take away from what we did and possibly, hopefully benefit from it. So yeah, my name is William. I run the open source team at TrailofBits. If you don't know us as a company, we're a relatively small consultancy. We're based in New York City, roughly about 150 people these days. Our primary proficiencies are program analysis research, compilers, cryptography, and then specifically open source within those domains. So we do a lot of contribution to tools like LLVM, to CPython, to the Python ecosystem, and those things. Happy to talk more about that later, but yeah. Before I actually get into the sort of details of this talk, I want to do a couple of thank yous because this work is all open source. It was paid for by people who are deeply invested in the open source community. So very first, I wanted to shout out Dustin Ingram and the Ghost team. I know a few of you are here. So this work would not have been possible without your funding. You have an incredible vision for the future and the security of PyPI, so thank you. The maintainers of PyPI itself, Donald, Ian, Mike, all reviewed this work and ensured that a smooth outcome was possible. They're also members of PyPA, which is the umbrella organization that PyPI is under, especially Svatoslav, who was extremely comprehensive in his review. And then finally, the Python Cryptography Authority were early guinea pigs for this work, and so I wanted to thank them specifically for making sure that everything was usable on the first day. Yeah, so basically I wanted to start with this. Does anybody know, I don't know how many people in this room are Python developers on a daily basis, but this is a screenshot of GitHub Actions with a workflow step. Does anybody know what's wrong with this picture? Can anybody see? If not, I'll just share it, but I wanted to start with that. Yep.
Not tied to a commit hash or a commit? Yeah.
That is something that's wrong with it. That's not what I was thinking of, but that is a good thing. It's good. No, so what I was thinking of was that there's no credentials. This use of the workflow didn't actually submit anything. It was going to fail at runtime just because it had no credentials specified. And actually that's a lie because something was right with this picture, which is this now works. And this entire talk is going to be about how this magic works. And I put this picture in because I thought I wouldn't have to explain it, but I actually do have to explain it because I have to give a talk. So I actually do have to explain it. But yeah, so because I know not everybody's a Python developer, I want to do a quick background on PyPI and its role in the Python ecosystem. So first of all, PyPI is pronounced, well, one of the emojis didn't render, but PyPI, not PyPI. It's the primary package index for the Python ecosystem. Speaking roughly today, it has about 500,000 packages on it, 5 million releases of those packages, 9 million files within those releases, and then about 750,000 users who overall download about 20 billion downloads per month from PyPI. This is all maintained by a small community of volunteers with some corporate funding. And so in terms of important things to know about PyPI, it was historically a massive legacy code base, which was rewritten in 2017. And ever since 2017, there's been a number of key security features that have been added to it. So in 2018 and 2019, TrailofBits helped add API tokens to TOTP and WebAuthn to PyPI. We also added security event logging and a whole bunch of other features for corporations to audit their own behavior on PyPI. The year after that, we helped add malware scanning to PyPI, followed by vulnerability feeds, GitHub secret scanning integration. And then finally, this year, which is what I'm going to be talking about, we added trusted publishing. So yeah, basically do like a then and now sort of what authentication of PyPI looked like. Prior to 2019, authentication of PyPI pretty much looked like what every package index sort of looks like as a baseline. It had username and password pair authentication. So when you uploaded a PyPI, including in CI, you would take your username and password, you'd put it as like a CI secret somewhere, and you would just push to PyPI. This has all of the downsides that you typically associate with username and passwords. There's no credential separation, so any project that's under your account can now be uploaded to via that password. If you just happen to commit that into a public repo somewhere, someone can just sort of like Google dork or GitHub dork for it and find it. There's no obvious revocation path. If someone just takes your password, they can just take over your account. And there's no real security events prior to 2019 for these things. However, starting in 2019, we added macaron-based API tokens, which more or less resolved most of these problems. So specifically what they do is they add configurable scopes. You could scope a token down to a single project or multiple projects. You could also scope in all projects, like a user level scope. So you could have something that was equivalent to your original password, but without actually putting your individual password into a CI system somewhere. They're also integrated into secret scanning for GitHub and security events, yada, yada, yada. However, there were a bunch of downsides associated with them too. So, also, by the way, I talk really fast, so if I'm going too fast, please tell me to slow down. Thank you. I will try to slow down. Unfortunately, they still need to be manually configured. You still have to go onto PyPI, log in, add a token, configure its scope, etc. They're also too easy to overscope. By default, the default scope is a user scope, or you might add too many projects to a single token that aren't actually needed because you aren't sure ahead of time what you actually require. And then finally, what I think is the biggest issue is that there's a sort of chicken and egg problem with API tokens for package indices. Thank you. The chicken and egg problem being that you want to create a token that is scoped for the smallest possible unit of work. But to do that, the project has to first exist. And for the project to exist, you have to upload it. And to upload it, you have to have an API token that's scoped to it. And so you create a user scope token first, upload the package, delete your user scope token, create a new token, scope it down, add that to your CI, and then publish a new version with that scoped down token, which is a terrible, terrible flow, if I'm being blunt. So yeah, that should hopefully explain why we want to do better than API tokens. Basically, they're still somewhat manual. There's these weird problems that are associated with them, like chicken and egg style problems. We want to remove those things through automation. So specifically what we want is no more manual token transfers. The CI/CD system, and you should be using CI/CD to publish Python packages, should receive their credentials automatically through some trust scheme. We want, this says maximum scoping, that should be minimum scoping. Credentials should be scoped down to the smallest unit of work that they're responsible for. There should be no user level tokens. There should be no tokens that are scoped for more than one project at a time unless multiple projects are publishing at the same time. And then finally, we want misuse resistance. That is like the number one thing in all security protocols is the user, unless the user should not be able to misuse your tool. Users can't leak credentials that don't exist. And so we want, ideally, credentials that do not exist in some sense. And that brings us to OpenID Connect. So the thing that is important to understand here is that CI/CD providers like GitHub support machine identities, and they support machine identities through a protocol called OpenID Connect. These identities are credentials. They're strongly bound to the repository and the workflow that created them. And so when you use these identities, what you're actually saying is, I attest that a workflow running in this user repo slug created this token, and any third-party entity that knows how to can verify that fact. And this is an incredibly useful primitive to build off of. One of the cool things about this primitive is that it's a short-lived primitive. So it's all based on JOTs, and JOTs are or can be short-lived and scoped to an intended audience, a target that is meant to receive the token, so that third-party audiences can't be spoofed, given a token that they don't expect. Basically, this reduces possibilities for compromise. And again, another nice thing here is that this is not new work. OpenID Connect is widely used throughout the industry, and it's widely applied to other services. So GitHub and AWS are already publicly document integrations between each other using OpenID Connect. GCP does the same. And so the question is, why not PyPI too? And that brings us to trusted publishing, which is exactly under the hood, OpenID Connect for PyPI publishing. So the rough idea that I want to give you as inspiration for other package indices is ahead of time, before you even create a project or publish a project, you will log into PyPI or your package index. You will configure a trust relationship between your project on the package index and the repository on GitHub or another repository system that supports OIDC, essentially saying that this project trusts this repository to publish for it, or this workflow within that repository to publish for it. The cool thing there is that trust relationship isn't secret, right? The repository itself is public, the workflow is public. Nothing that you do there can be leaked in any meaningful sense because there's no private information. And like I said, for GitHub specifically, that trust relationship is the user repo slug plus the workflow name, such as release.yaml, and then optionally an environment name if you want to scope it down to a specific environment within your GitHub actions. And then to actually use this thing that you just configured, you've just configured. Essentially what you'll do is the OIDC provider will create an OIDC credential running in your workflow. Your workflow will take that credential, give it to PyPI. PyPI will exchange it for a short-lived API token that it understands, and then you will authenticate with that scoped-down API token for the project that has been configured for. And the cool thing about all of this is that this all works above the authentication layer for the index itself. So the index only sees the original API token. So from the index's perspective, all you're doing is normal API token authentication, but you're giving it an API token that has been scoped down and created from an ephemeral credential that is much, much less valuable as a credential to steal from an attacker's perspective, and is much harder to steal because it is not pre-configured or shared in any way. Yeah, so here's the bird's eye view for that, and oh, good, it is big enough. So basically, this shows you the trust and authentication flow for trusted publishing on PyPI. So as a user, what you'll do is you go to PyPI and say, I trust release.yaml for my spam for project foobar on GitHub to publish for the project spam on PyPI. And then basically PyPI will take a note of that and say, oh, okay, I trust OIDC credentials for that repo and workflow from GitHub to publish for spam. Then you will push or trigger a release on GitHub for foobar, and your release workflow will grab that ephemeral OIDC credential, pass it along to PyPI. PyPI will say, oh, that credential matches something that I know about. I will issue you a temporary API token. The workflow will then use that API token to authenticate to PyPI and publish the actual credential. And so critically there is no actual pre-shared API token between users. Thank you. But you'll notice this does not solve one of our issues. It doesn't solve the chicken and egg problem. With this, you still have to have a project to configure to because you went on to PyPI and you went to a project name and added a trusted publisher to it. So we still want to solve that problem. And so to solve that problem, we came up with another solution, which is what we call pending publishers. And so for a pending publisher, it's sort of registered similarly to a trusted publisher, but rather than being linked to a pre-existing project, it's tied to your account, and it includes the project name that you expect to publish with that publisher. And so the flow is exactly the same, except that on first use, the project is created, and then the publisher is reified into a full trusted publisher after use. And so as a bird's eye view of that, it's almost identically the same. It's almost identical, but instead of immediately creating an API token for the project, it first creates the project, and then passes an API token for that newly created project, which is scoped down to just that newly created project. Yeah, and the cool thing is that it works. With this scheme, we achieve basically all of our goals. All the credentials that we create are temporary and self-expiring. They cease to be valid after 10 minutes. All credentials are minimally scoped. There's no user scopes, and there's no projects that are scoped, except for the ones that are directly configured for the trusted publisher. The user only performs configuration once for the trusted setup configuration. And then all configuration is public information. There's no private state shared between PyPI and the user during configuration. And we finally, and most importantly to me, we eliminate the chicken and egg problem with API tokens. And this is all really cool, but I think there's also two other things I wanted to highlight in the context of supply chain, which I know a lot of people in the audience care about. We solve two critical supply chain problems in the same process. One thing that we do is that we sort of like flatten the state. The source repository itself becomes the ground truth for authentication. There is no more like mysterious step that happens from source repository to artifact to index. The repository itself is directly responsible for authentication and publishing. And then finally, we simplify transitions of maintenance between maintainers of projects. There's no longer this hot potato game of like passing the API token to the new maintainer or like adding them to the project and deleting yourself and revoking all your credentials. Now, the repository itself is the credential, and anybody who owns the repository has publish access, which I think is a really cool outcome. Yeah, so that's the high level. Now I want to get into some nitty-gritty stuff in terms of lessons for other possible implementations. Yeah, so not all is peaches and roses. This is structured in terms of lessons. So the first lesson that we learned the hard way is that the data model for this stuff is pretty unintuitive. Your first impression might be, oh, well, you have one package and you have one repository, so you have one trusted publisher per repository per package, right? This quickly like smashes against reality. The reality is that multiple projects for most packaging languages, or most languages, people put multiple projects in the same repository, usually for good reasons. And then therefore they live under the same logical publisher in that repository. The canonical example of this for a company would be like a monorepo, or for a Python package, something like the package and its native extension and yada, yada, yada. And then the inverse of this is also true. You have multiple logical publishers that are responsible for a single project. And this one is a little bit less intuitive. The example here is that you have a Python package that has multiple builders for different architectures. And so ideally, what the user would do is they would fan out all their builds, and they would fan back in their builds and do a publishing thing in a single step. But enough people don't do that, and we don't want to break people while rolling this out initially, that we would rather just support this sort of unideal deployment model. So the conclusion here is that trusted publishing is actually many, many, and this has sort of surprising complexity implications for your underlying data model. And so this isn't going to be interesting unless you care about PyPI's internals, but basically you have a many association internally between publishers and projects, which is kind of gross, but you sort of have to live with it. Second lesson. OIDC is very, very, very narrowly standardized. And so again, the thought here is like, oh, it's just JOTs. How different could they be? And the reality is that they can be very different. Individual providers have wide latitude over the claims that they support, the availability of those claims, and the individual internal formats of those claims. Pretty much as a consumer of OIDC tokens, the only things you can actually assume are the issuer claim, the expiration claim, the audience, and 2 or 3 others that are pretty basic. And even these have weird subtleties to them that I'm happy to talk about offline. So basically, as part of adding support for a new publishing environment, you have to very carefully look at existing tokens, which are usually not well documented by these providers, figure out what the claims are within them, what are the sufficient claims for an identity within that provider, and then fine-tune your verification process for those claims. This requires in-depth knowledge of each provider, essentially, and is somewhat tedious to do. Basically the conclusions here are supporting multiple providers requires a lot of even more data model complexity, and then adding new trusted publishing providers such as GitLab or Google is somewhat time intensive, and ecosystems should prioritize providers that they see the most. So for PyPI, that's GitHub, but obviously we would love to support Google, GitLab, et cetera, as we have the time to build them in. And so again, just some more pain that appears. The data model continues to get more complicated. We now have these like mix-ins for different things we can expect. So it gets worse. Lesson 2.5. OIDC varies widely even within identity providers. And so the assumption here, which you might reasonably make, is that every OIDC credential that you get from a specific provider like GitHub should look basically the same internally. And this is not true. They've basically, depending on the way that the credential is created and the scopes under which it's created, they can vary wildly in structure and form and claim values. And part of reliably surfacing either error messages or successes to users is handling all those different values. And one of the scary things that can happen here is that, providers can just change these things internally willy-nilly, and you only learn about them when users start reporting that their publishing actions no longer work. And so we spent a lot of time working with GitHub specifically to make sure that we were not unduly relying on claim formats that they expected to change in the future. And even still, we experienced some breakage. Conclusion here is supporting every possible configuration of a trusted publisher is pretty hard, and trying to do so opens up some potential logic errors. So scope down what you need to support, focus on that thing, and then ideally work with the IDP to figure out how best to support it. More data model complexity. We now have lookup strategies, which I hated writing this, but I had to write it, so now you have to see it. Lesson number 3. OIDC credentials are not API tokens. This one comes, if you've followed the previous slides, you might think, wait a second, the workflow created a token for me, why don't I just send that directly to PyPI and use that as my API token, right? And the answer to this is that technically you can do this. It is a credential. It's one that we can verify, and we know the scope to it. However, I would strongly recommend, if you were looking to build something symmetralist for your package index or to support it for another package index, not to do that. The main reason not to do this is that those OIDC credentials are not going to be plugged into your pre-existing auth and auth systems or your pre-existing permission and scoping systems. You will essentially have to duplicate that work and reintegrate a new credential format into your systems. That opens up potential for logic errors that you otherwise wouldn't have to deal with if you do an exchange. OIDC credentials themselves are actually very large. They're much larger than a typical API token, even a PyPI API token, which is pretty big. That's not, you don't want to deal with that size. And also, sort of concerningly, there is all kinds of stuff in an OIDC credential that is not necessarily relevant to verification that you don't necessarily want to hold on to. Things like PII, email addresses, phone numbers, user identifiable information that should not be living on PyPI side. PyPI ideally holds on to that for as little time as possible, converts into something that it knows is somewhat anonymized, and sends that back instead. And then finally, as a matter of sort of reliability and stability, IDPs can change expiration and other policies without notice. Creating your own temporary token provides a unifying sort of a leveling space for making sure that your tokens don't expire sooner than you expect. So the conclusion here is that exchanging the OIDC provider's credential for your own API token internally minimizes the amount of novel code, reduces logic errors, and gives you additional resilience against IDP changes. Okay, next lesson. Words are hard. This is a quick survey of all the ways that people reacted when we released this originally. They really, really did not like the name Trusted Publishing. The interesting thing here is that all of these screenshots are mostly from people who do not publish on PyPI. The people who actually publish on PyPI thought the name was incredibly intuitive. But I think this is still useful information to have because it shows that if you don't know PyPI publishing already and you were told to use a trusted publisher, you might not have any idea what the person is actually trying to tell you. And so we ultimately decided not to change the name just because it was already baked into so many places and because we found that PyPI users themselves already understood what we were trying to say. But this is worth noting for people who are potentially looking to integrate this into other packaging indices. Okay, our last lesson. It's all worth it. OIDC is really complicated. The trusted publishing model on top of it is even more complicated for all those things that I showed earlier about data model and IDP unreliability, et cetera. However, the user and security gains make it entirely worth it in our experience. The user feedback, once they understand this feature, is overwhelmingly positive. There is extremely high demand for additional support for IDPs now that users understand how it works. They want support for GitLab, they want support for Google, et cetera, as well as support for reusable GitHub workflows, which we're currently working on. And then we've also seen adoption by critical projects. These slides are a little bit out of date. Basically, over the last few months, we've seen a large number of Python's critical projects adopt trusted publishing and use it to publish new releases. And the cool thing to note here is that even though these numbers seem really small, these are critical central dependencies within the Python ecosystem. So Python's download distribution is extremely skewed towards like the 200 or 300 critical projects that everybody downloads when they set up a Python project, things like cryptography, requests, URL, lib3, IDNA, et cetera. Those things everybody uses, and those things now use trusted publishing, which is, in my opinion, really cool and really like a key win for this feature. And yeah, this is just a screenshot from one of our happy users. Yeah, so then just a quick thing for the future. So this is where we are today. The logical thing to ask is, well, what comes next from here? One thing that I think is really cool about this work is that all the building blocks that we built for PyPI here are things that enable us to build provenance and code signing for PyPI as well. The things that we're using under the hood, OpenID Connect credentials, claim verification, are the things that Sigstore uses internally to bind developer identities or machine identities to source artifacts. So much of this can be reused to integrate Sigstore into PyPI. And so the goal here is that any ecosystem that supports trusted publishing should have a very natural and easy on-ramp onto code signing as well. And that's the goal. Yeah, so a couple of conclusions. Basically, as I said before, I believe that trusted publishing is a double win. It's both a security win and, this is my sort of, I don't know, spicy take, is that security wins are only valuable if they're also usability wins. Anything that is a security win also has to be good for users. The best kind. Yeah, I don't know, I wrote that there. Yeah, another big takeaway from this is that trusted publishing is not actually tied to PyPI. Even though everything I've shown is PyPI specific, the fundamental operation here is an OIDC exchange to an API token that's hosted by a package index. Any package index can do that. We have learned a lot from doing this for PyPI. We would love to talk to package indices and maintainers in this room, as well as people you know, to help basically facilitate this work on other indices. And then, like I said with Sigstore, trusted publishing is a logical step towards our sort of shared supply chain goals. Things around source and build provenance, code signing, and then generalized verifiable attestations over source and dependency graphs. This is basically the baby step in the process. And with that, thank you. These slides will be online. I think they're also on the EU site, and then there's some links here. Happy to take questions if I have. No, I don't think I have time. Yep.